Good day, everyone, especially to Mom Jemren and Mom Angelica. We are the House of Gamaliel, and we're going to present the week 2 of Mathematics Talk entitled Probability Distribution, and we're going to discuss furthermore about random variable and the different types of events.
Here are the three objectives in this lesson. First, to understand the concept of probability distribution. Second, to explore the different types of random variables. And lastly, to analyze the relationship between random variables and events in probability distribution. So, what is probability? Probability quantifies uncertainty and is used to predict the behavior of random events in various situations. It is a measure of the chance that a given event will happen, expressed as a number between 0 and 1, where 0 indicates that the event will not occur and 1 indicates that the event will certainly occur. Here is a real-life example. When you flip a coin, there are two possible outcomes, head or tails. The probability of getting heads is 0.5, which is 50%, and the probability of getting tails is also 0.5. When you look at this, the experiment of this is tossing a fair coin. The event is getting heads, and the outcome is heads. The sample space is S equals heads and tails. The probability of heads is equals to 1/2.
Here are the basic concepts in today's discussion. Simple and compound events. These events are classified based on the number of outcomes they encompasses. A simple event is an outcome or a single result of a random experiment. So what is a random experiment? It is a process with an uncertain outcome, but with a known set of possible outcomes that can be repeated under similar conditions. Simple events cannot be broken down further into smaller events, and you can think of it as the building blocks of all other events. Let's jump into the examples of simple events. Number 1. You choose a shirt to wear in the morning, picking a blue shirt, flipping a coin, and getting heads. It will rain tomorrow. Those are the examples of simple events. Now, here is the probabilities of a simple events. Probability of an event equals the number of favorable outcomes over total of numbers of outcomes. For example, what is the probability of spinning a green? So our number of favorable outcomes is 1, and the total number of outcomes is 4. Then 1 over 4 is our answer. In conclusion, the probability of spinning green is 1 out of 4, or 25%. Compound event consists of two or more simple events. It is a combination of outcomes. Compound events often involve words like and, or, at least, or at most. Compound events are often relevant in real life because many problems involve multiple events and contributing causes. For examples, it will be sunny and above 70 Fahrenheit tomorrow. It's another compound event. A plant is watered, it grows, and it flowers. The probabilities of compound events will further discuss in this video.
Now we will further examine the types of events like independent and dependent events, mutually exclusive and inclusive events. These events are connected to the two events that I have mentioned before. Let's see. Independent events. What is the definition of independent events? These are events where the occurrence of one does not affect the occurrence of the other. Example, rolling a dice and flipping a coin, selecting a card from a deck, replacing it, and then selecting another card. And independent events, these are events where the outcome of one affects the outcome of the other. Example, selecting a card from a deck, not replacing it, and then selecting another card. Other one is choosing a student for a team and then choosing another from the same group. Mutually exclusive and mutually inclusive events. Mutually exclusive events, these events cannot occur at the same time. If one happens, the other cannot. And, and, and its example is flipping a coin. The result is either heads or tails, but not both. And the next example is rolling a dice. Getting a 3 and a 5 simultaneously is impossible. And for mutually exclusive, these are events that can occur at the same time. And its example is choosing a student who is both a basketball player and a scholar. And another one is drawing a card that is both red and a king from a standard deck. In short, mutually exclusive and inclusive deals with the overlap of events, while dependent deals with the influence of one event on another. Both concepts can apply to both simple and compound events.
Addition rule for probability description. This is used when calculating the probability that at least one of the two events A or B will occur. Rule number 1. When two events A and B are mutually exclusive, the probability that A or B will occur is probability of event A or B equals the probability of event A or B. Example, event A rolling a 2, event B rolling a 4. The probability of rolling a 2 is equals to 1 over 6. The probability of rolling a 4 is also equals to 1 over 6. So 1 over 6 plus 1 over 6 equals to 2 over 6. If we round off, this equals to 1 over 3. Therefore, the probability of rolling a 2 or 4 is 1 over 3. Rule number 2. If A and B are not mutually exclusive, then probability of event A or B equals probability of event A. Probability of event B minus probability of event A and B. Example, a card is drawn from a standard deck of 52 playing cards. What is the probability that a card will be a spade or 7? Probability of event A or B is equals to 13 over 52 plus 4 over 52 minus 1 over 52. It's equals to 16 over 52 equals to 4 over 13. Multiplication rule for probability is that we use calculate the chances of two or more events that occur in sequence. Probability of the intersection of two events is called probability. Rule number 1. When two events are independent, the probability of both occurring is probability of events A and B equals the probability of event A multiplied the probability of event B. Example, set A rolling a 4 on a dice, and B leaving a head on the coin. Probability of event A is equals to 1 over 6. Probability of event B is equals to 1 over 2. So it's 1 over 6 multiplied to 1 over 2 is equals to 1 over 12. The probability of the both events happening is 1 over 12. Rule number 2. When two events are dependent, the probability of both occurring is probability of event A and B equals the probability of event A multiplied the probability of event A or B. Example, event A drawing an ace in the first round. Event B showing an ace on the second draw after the first ace has been drawn. Probability A is equals to 4 over 52 equals to 1 over 18. Probability of B is equals to 3 over 51 equals to 1 over 17. So it's equals to 1 over 13 multiplied to 1 over 17 is equals to 1 over 221. Rule number 3. When two events are mutually exclusive, their joint probability is N is a 0. The probability of event A and B equals to 0. Example, event A, rolling a 2. This means a dice will show 7. Event B, rolling a 5. This means dice will only show 5. Probability of event A and B is equals.
Next is the random variable. A random variable is a variable that takes on numerical values determined by the outcome of a random experiment. It maps the results of an experiment to numbers, allowing for mathematical analysis of probabilities. And here are the examples. Number 1. Rolling a die. The outcome of a rolling six-sided die where the random variable represents the number on the top face. Number 2. Tossing a coin. The random variable could represent the number of heads obtained in tosses. Number 3. Measuring rainfall. The amount of rainfall in a day is a random variable. There are two types of random variable. First, we have discrete random variable. A discrete random variable can take on only a finite or countable number of distinct values. And now for continuous random variable. A continuous random variable can take on any value within a given range, including fraction and decimals.
Definition of probability distribution. Probability distribution is a mathematical function used to measure how probable various outputs of an experiment is. In a case of a random experiment, it also assigns each possible outcome a probability, which is the chance that an individual outcome occurs. For example, random experiment, any activity or process with an unpredictable outcome, such as for example flipping a coin, rolling a dice, or measuring the height of a random selected person. Probability, a number between 0 and 1, 0% and 100% reflecting the likelihood of a certain outcome. Probability distributions are very common in many fields. Examples, statistics for the analysis of data and inferences, finance for asset price and risk modeling, engineering, system design, within with some random variations are treated. Machine learning is one of the predictive models. Many distributions are there, two of which have their own uniqueness. Here are the two types of probability distribution. Discrete probability distribution. This will cater to variables that will hold a finite amount or countably infinite amount of values. Bernoulli distribution, it narratives the probability of success and failure in a single trial.
Characteristic of discrete probability distribution. Discrete probability distribution describe what is the probability of occurrence of each value of the discrete random variable. Its chief characteristic include non-negativity. Probability of each and every event is a non-negative value, that is p parenthesis x equals 0 for all x. Second, normalization. The total of all probabilities of each event for which an experiment is performed equals unity. That is p parenthesis x equals 1, where the summation is taken over the values x which the random variable x can take.
There are three possible outcomes in the sample space. The sample space is the set of all possible outcomes. In this case, the possible outcomes are the colors of the marbles. Let's define the random variable x as the color of the marble selected. The frequency distribution is a table that shows the number of times each value of x occurs in the sample space.
Distribution of the values of random variable. Let's define the random variable x as the color of the marble selected. The frequency distribution is a table that shows the number of times each values of x occurs in the sample space. The key knowledge: random variable. A variable whose value is a nominal outcome of a random experiment. Frequency distribution. A table that shows the number of times each value of a variable occurs in the dataset. Step 4. Construct the probability distribution of the random variable by getting the probability occurrence of each value. The probability distribution is a table that shows the probability of each value of the random variable. To calculate the probability of each value, we divide the frequency of the value by the total number of marbles. Key knowledge: probability distribution, a table that shows the probability of each value of a random variable. Probability: the likelihood of an event occurring. Step 5. Construct a probability histogram for illustration. The answer: a probability histogram is a bar graph that shows the probability distribution. The height of each bar represents the probability of the corresponding value of the random variable. Lastly, and the key knowledge: probability histogram, a bar graph that shows the probability distribution of a random variable. And thank you.
Characteristic of continuity probability density function. A probability density function, or PDF, gives the probability density of the succeeding values of a certain proportion of continuous random variable. Its key properties are non-negativity. The probability density does not take any negative value anywhere in the region of the random variable. That means f (x) equals 0 for any x.